I will just mention in passing a question that often comes up, and this isn't necessarily the world's greatest explanation, but there's often a question of if this hydrogen bonding is due to a stronger difference in polarity, a stronger electronegativity difference, why isn't chlorine included? So again, if we look at the atoms that are involved in hydrogen bonding, we've got this slightly positive hydrogen with a slightly negative nitrogen, oxygen, or fluorine. And when we wrote those electronegativities out, nitrogen was a 3.0, 3.5, and 4.0 for electronegativity. And then hydrogen was a 2.1, wherever you want to write that. The question then comes up, why not something like chlorine? Now I guess we should say slightly negative chlorine. If you look at the electronegativity on chlorine, it's 3.0, which puts it right up there with nitrogen in terms of electronegativity difference. And I think that the explanation that you'll commonly see is either A, well, maybe there's more stuff that is involved in hydrogen bonding than just nitrogen, oxygen, or fluorine. But if we're going to stick to that definition, I think that size comes into play, and the attraction between size comes into play. Chlorine is in the third period, the third main energy level, as opposed to nitrogen, which is up here. So it has an additional S and P sublevel, distancing the nucleus from those outermost electrons. So I think often the justification for chlorine not being included is size, and that size having a factor in terms of the charge distribution between the slightly negative species and the hydrogens. So even though it's got a 3, I think that the simple explanation is size.